All right, in this video, we'll be converting and showing how to convert from decimal to binary. So first things first, decimal numbers are in base 10. That's one thing you want to remember. And binary numbers are in base 2. So those are the two main concepts of this section, right? So as we get started, the main way that you want to look about it is that decimal numbers are made up of, since they're base 10, they're made up of 10 digits. So that make up the whole number system. So 0, 1, 2, 3, 4, all the way up to 9. And those make up all the numbers. And then in base 2, the numbers that make up the system are just 0 and 1. So a number in binary can be something like 10101, or it can be 101 or 0011, which would be the same as just 11 because the two leading zeros would be irrelevant. And then base 10 is what we're familiar with. So it could be 10, 9, 21, 105, so on and so forth. So we'll start off with the first method of converting from decimal to binary, and then I'll show the other one and a few examples of both. And you can choose which one works best. It's completely up to you. There's no better or worse way. So the first way, we'll start by saying, let's try to convert 75 to decimal. Okay, so 75 and base 10 to decimal. So the way you want to do this is that you want to put the stage of what a base 10 number is. So what a base 2 number is. So it's going to be 2 to raise to the power of a number. So first of all, you have 2 to the power of 0, and this is how numbers work. So 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 5, and so on and so forth. Similar to how in a base 10 number, the first digit is 10 to the 0, it's the tens, and then 10 to the 1, and then 10 to the 2, and so on and so forth. So you have the ones digit right here, the twos digit, and the tens digit, and the hundreds digit. So similarly, this is how it is in a base 2 number system. Okay, so you want to write it out. So you have 2, 4, 8, 16. Sorry, you have a 1 here, 2. 1, 2, 4, 8, 16, 32, 64, and 128. Okay, I'm only writing up to 128 because, as you'll see, any more is redundant because you're going to work retroactively and see how you can fit 75 into the number system. So first of all, we're going to start with 75 and comparing it to 128. So does 75 fit into 128? As in, is 75 greater than or equal to 128? The answer is no, right? It's quite obvious, so we put a 0 right over here. I'll put this in blue just so you can see that this is the answer. And then we go on to the next one. So does 75 fit into 64? Yes, it does. So we do 75 fits into 64, so we put a 1, okay? And then we update the number that we currently have. So 75 minus 64 is 11, okay? So we go on, we're comparing 11 to the remaining numbers. So now we compare 11 with 32. Does it fit? No. Does it fit into 16? No. Does it fit into 8? Yes, so we put a 1. And then 11 minus 8 is equal to 3. And then I'm just going to go on and fill out the rest. You have a 0 going to 4, and then you put a 1 into the 2 spot. 3 minus 2 is equal to 1. You're left with 1. You put the 1 over there. And then we see that 75 has been converted to the following in binary, where it is 1, 0, 0, 1, 0, 1, 1. Okay? So this is the first method of converting, where you write out all the numbers that you have in the base 2 number system, and then you work backwards to try to fit the decimal number into the binary number system. We'll do one more example, and then I'll show the next method. So let's try a little bit of a bigger number, where let's say it's 100. Sorry, let's say it's like 210. Okay, a little bit of a bigger number. So we write it out again. So we have, let's start from this side. We have 1, 2, 4, 8, 16, 32, 64, 128. Okay, and remember, once again, this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. Okay, so we go on and we try to fit it in once again. So 210 trying to fit into 128, it fits. You put a 1 right over here, and you subtract, and you see what you're left with. Okay? So when you subtract 210 by 128, you're left with 82. And then I'm gonna work through this one a little bit faster. So you see 82, does it fit into 64? Yes. So 82 minus 64, you're left with 18. Okay? And then as you can see, everything else is gonna be a 0 except the 1 in the 16 spot, where 18 minus 16, you're left with 2. So you put a 0, 0, 1, 0. So we see that 210 in decimal becomes 1101 0010 in binary. And I'm writing them in blocks of 4 just because it's easier to visualize when you're looking at the number, because multiple zeros next to each other can look confusing, and this is general convention of writing binary numbers where you write them in blocks of 4. So yeah, so that's the first method. I've shown 2 examples. We're going to go ahead and show the second method. I'll use the same number that I've used before, just so you can compare that it is the correct answer. So I'll copy this over here. So we saw that 75 gave us the following when we converted it to binary. So we'll do it again in this method. Okay. So this method warrants that you're going to want to divide and then find the remainder of the division. So, and what you're dividing by is the base of the number that you're converting to. So in this case, we're converting from base 10 to base 2. So you're going to divide by 2 at every single step. Okay. So 75 divided by 2 is 75 divided by 2, you're going to get 37 with a remainder of 1. Okay? And then we divide again. 37, we take this number right here and put it down here. Okay? And then we divide this again by 2. And we go on again. So 37 divided by 2, you're going to get 18 with a remainder of 1. Because 18 by 2 is 36, and then your remainder of 1. Okay? And then we go once again. 18 divided by 2, you're going to get 9, remainder 0. And then 9 divided by 2, you're going to get 4, remainder 1. And we're going to keep doing this until this number right here is 0. Okay? Till there's no more to divide. So then we go on again. 4 divided by 2, you get 2, remainder 0. And then you get 2 divided by 2 is equal to 1, remainder 0. And then 1 divided by 2 is equal to 0, remainder 1. And then we're done because we have 0 over here. Okay? And then this right down here is going to be your most significant bit. And this up here is going to be your least significant bit, the LSB and the MSB. The reason we call it the most significant bit is because it carries the most weight. As in, this is the value that holds the value of 2 to the power of 7, or in other words, 128. And this holds the value of 2 to the 0, or in other words, 1. Okay? And what you're going to want to do is read this number backwards, from the bottom upwards. So as you can see, if we compare it to the number that we have up at the top that we verified previously, you can see that 75, if we read it from the bottom, 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 1. So you read it from bottom up. So you end up again, 1, 0, 0, 1, 0, 1, 1. Okay? Yes, yeah. Sorry, I messed up over there. Right there. So we've confirmed that this method works once again. So finally, I'll just show the example again for the previous number to help you work through it, and we'll be done here. So once again, a little bit quicker, we'll go through 210 divided by 2 is equal to 105 with a remainder of 0. And then 105 divided by 2 is equal to 52 with a remainder of 1. And then 52 divided by 2 is going to be 26 with a remainder of 0. Then 26 divided by 2 is going to be 13 with a remainder of 0. And then 13 divided by 2 is going to be 6 with a remainder of 1. And then 6 divided by 2 is going to be 3 with a remainder of 0. And then 3 divided by 2 is going to be 1 with a remainder of 1. And then 1 divided by 2 is going to be 0 with a remainder of 1. And then we're done. Once again, because we've reached 0. And once again, to confirm, let's see what we have. So we have 1, 1, 1, 1. They match. 0, 0, 0. What? 1, 1, sorry. 0, 0, 0, 0, 1, 1, and 0, 0. And once again, just to remind you, this is our least significant bit. And this down here is our most significant bit. And this concludes our tutorial on how to convert from decimal to binary. In the next one, we'll probably go over how to convert from binary to decimal.